Picking up where we left off last time. Reminder, definition of a function. Yeah. They're $5 now that class has started. It's not a funny joke, but it's funny. I gotta say something. Okay, so reminder, definition of a function. Okay, a function is a relation. Okay, this should already be in your notes. I'm gonna write it again because I am that sort of wonderful professor. Okay, a function is a relation. In case you weren't here, a relation is simply a set of ordered pairs. It defines a relationship. A function is a relation in which each x value corresponds to a single y value. So function is a relation. It's a relationship between my x's and my y's and my ordered pair in which each x value corresponds to a single y value. And we ended our time last time by looking at the relations on the front and determining if they were a function or not. I told you a simpler way to think about that's the mathematical definition of a function. A simpler way is when you look at your set of ordered pairs, if you can say that each x is listed once, then you have a function. Okay, it means each x corresponds to a single y. So just to get ourselves back up to speed before I define the next two things, which you've probably heard those words before, exercise 5, or excuse me, example 5 and exercise 6. The function, or excuse me, the relations are given as tables. I want you to determine for each of them, is it a function or not a function? Function or not a function? Does anyone else need one of the sheets? The first table, this relation right here, does this represent a function or not a function? Why is it a function? Each x is listed once, right? Which means each x has a single y value. Okay, great, this is a function. How about this one, the second one? Is this a function or not a function? Why is it not a function? The -3, or also the 7, doesn't matter, it only has to fail one time. That means the x value -3 corresponds to more than one y value. In this case, 10 and -9. That's why it's not a function. I will come back to the mappings that are down at the bottom, but before we do that, there's two other things that we're going to talk about with regard to our functions before we dive a little deeper and make this look a little more college algebra. I don't know what I'm trying to say there. The domain. You've heard these words before. I told you this whole section is a review of something you did in intermediate algebra. Okay, but it's super important because this is what we're going to dive into this semester. It's functions, how they behave, what they look like, all of that. So what's the domain refer to? Anybody remember? The x values. Yep, the domain is the set of x values. The range. Anybody remember what that word is referring to? Yeah, perfect. The set of y values. Great job. Thank you for participating. Let's flip back over to the front page, okay, where our initial examples were. And so, I mean, I know you've done this before, so we're just gonna do a couple of these. So if you would please write down the domain and the range for example 4 on the left and for set C on the right. Okay, set A and set C. Please write down the domain and the range. For A, the domain, I'm just going to abbreviate. The domain is the set of x values. I'm going to write these in number order. It is not a requirement if you write the numbers in a different order, but the domain is -2, 0, 3, and 7, a set of x values. The range is the set of y values, so that's -6, -2, and then 3 and 5. Any questions about domain or range? For C, the domain is 2, 3, 7. And then the reason I had you do C is simply because when a value is repeated, you only have to write it one time in case you've forgotten that. So the range is just the value 4. Just because I'm giving you a look of all the different things that you are going to see at some point, if you would, the second table, exercise 6, real quick, write down the domain and range of that. Domain, set of x values. Hopefully you wrote down -3, 4, and 7. The range is the set of y values. And for this one, that's -9, -1, 3, 6, and 10. Again, any questions at all? When you take your test a week from today, there's going to be a couple problems just like this. So if you're feeling good, then you should be feeling good on that test. Okay, I told you the secret to passing the class on day 1 is if you know what's going on in class, I take stuff we do in class, which you've done on the homework, and I just put it on a test just to see if you're still awake. Okay, so I try to make this class, because it's hard enough as it is, I try to make it as simple of an endeavor as possible. The next 2 examples at the bottom of page 2 are both mappings. Mappings are another way to express a relationship. You use arrows to go from what x value corresponds to what y. So for both of those examples at the bottom of the page, will you please tell me function or not a function, and then do the domain and range for exercise 7. You don't have to do it for both, just for the second one, please. First mapping. Is this a function or not a function? It's a function. Each x value has 1 arrow leaving it, meaning it corresponds to 1 y value. Okay, 2 corresponds to -4, 7 corresponds to 5, 13 was 0. If you had listed them out as ordered pairs, if you needed to, then each x is listed 1 time. So this is a function. I did not ask you to do the domain and the range of that one. I asked for this one. How about this second one? Is this a function, yes or no? Why does this one fail? The -2. The -2 has 2 arrows. -2 corresponds with 0. -2 corresponds with 1. That violates the definition of a function, which says each x value corresponds to a single y value. So that's why this is not a function. We can still ask about the domain and the range, though. That doesn't matter. The domain is the set of the x's. It's just what's in that cloud right there. And then the range is just what's in the other one. I'm trying to keep things moving along, but I don't want to lose anybody. Okay, so I'm trying to make that balance of keeping this semi-interesting, but also not escaping anybody. Does anyone have a question where we are so far? Okay, so I'm going to switch camera views now. actually look like I know what I'm doing. I got you fooled. Okay, so what we're going to do now is example 7. I would like you to do this. Before we do example 7 and 8, I've got to define some points because right now it's just a blank Cartesian plane. So example 7, let's do these points right here. Let's go -4, 2. I'll label them just so that you can see. So -4, 2. Let's go 0, -6. There's nothing special about these points. I have no secret mysteries right here. And then let's go 5, 1. Then exercise 8, I think I can fit both of these on the screen at once. So exercise 8, let's go -3, 3. Let's go -3, -5, just to keep them kind of away from each other. Because I'm a messy writer. 0, 0, that's always a fun point. And then let's go 4, 6. And just because I'm feeling feisty, 7, -1. All right, I'm going to give you a moment to catch up with me. My purpose here is I want to show you a couple different styles of graphs because we're about to encroach on the most common mistakes students will make on this, and I want, hopefully, for you to avoid that. I want you to notice the difference between the graphs in example 7 and exercise 8 and the graphs that you see below it in the 4 other examples. Notice what I just had you do in example 7 and exercise 8 is you have just plotted a discrete number of points. On the left graph, it's 3 points. On the right graph, it's 5 points. And how we notate the domain and range for those is going to be different than how we notate the domain and range for the examples below. Because notice these are just nice, these are nice lines. That represents all of the values. It's not just a finite number of values. So we have to do something a little different for the domain and range. Okay, so I'm just hoping that I can make this clear enough that you avoid any mistakes. So for example 7, what would you say for example 7? Is example 7 a function or is it not a function? It's a function. We've listed out the x values. Each x occurs a single time. So yes, that is indeed a function. I'm just going to write the word function at the top of the Cartesian plane. And then the domain and the range. This is just what we were doing for the mapping or the table or the set of ordered pairs. I'm just going to use a D for domain to save me a little room. The domain here is -4 and 0 and 5. It's just the x's. And then the range is the y values, so -6 and 1 and 2. So I had 3 points. I just got the x's and the y's directly from each of those points. Everybody tracking with what's going on so far? Well, then take a moment for me. Exercise 8, if you would determine, is that a function or not a function? And then just real quick, do the domain and the range. I know you're bored with it, but humor me. I do have your best interests at heart. Is this one a function or not a function? Not a function, okay? And the reason it's not a function is -3 is associated with 2 y values. One of the things this picture tells us is a nice quick way to determine if a graph that I am given is a function or not a function. Does anyone remember the test? I'm sure you do. Vertical line test. And the reason the vertical line test tells me if something's a function or not a function is notice when I draw a vertical line right here, how many times does that vertical line hit the graph? Twice. It hits it at once at each of the different y values. So the vertical line test, in case you don't remember it, is a quick way to determine if a graph's a function. And the vertical line test is if a vertical line, if it touches the graph more than once, it's not a function. which is the answer for this problem. It's not a function because that x value -3 occurs once, and so it occurs more than once, and so because of that, it's struck by that vertical line in two places. I asked you to write the domain and the range. So the domain of this is -3, 0, 4, and 7. The range of this is equal to -5, -1, 0, 3, and 6. Anybody got anything different that we have to talk about? Okay. Well, then going to example 8, I'm going to work this one with you because I'm hoping that you'll see the difference, especially in how we write the domain and the range for this problem. Example 8. Well, by inspecting it, by using our new good friend, the vertical line test, is example 8 a function or not a function? It's not a function. Notice it only has to fail once, so I'm just going to draw a vertical line right here, and whoops, that vertical line hits the graph in two places. Okay, there's a top and a bottom point. So because of that, this is not a function. Now, because this graph is not just a finite number of points that we have plotted, we have to do the domain and the range in interval notation. Remember, the interval notation tells me all the values, and we practiced this at the beginning of the section. If you weren't here, then just watch the video that's posted on your Canvas shell, and you watch what we did for section 1.2, and you'll get yourself all caught up. So what we have to do for the domain is we're going to write it in interval notation. And remember, to write something in interval notation, we have the lowest value, then the highest value, and we either use brackets or parentheses on each end. So my domain, my x's, I'm looking left and right. When I'm looking left and right, what's the lowest x value that we have? -5. And as I go to the right, what is the largest x value this graph has? 5. Great. By the way, if you can do this, you're doing great. Reading graphs is going to be a huge skill this semester. So if you struggle with it, it's a great time to ask a question or hang out after class, and we'll make sure we get you all caught up. This graph goes through both of those points, so I am going to use a bracket on the ends. So the range. Now, this is a circle, so it's not super interesting. By the way, no tricks or gimmicks. I just couldn't get Microsoft Word to get any closer to the bottom -5. So I will never try to trick you with something like that. Always plan for the obvious. How far down does this graph go? What's the lowest y? Again, -5. What's the largest y? Okay, so again, my interval is -5 to 5, and whoop, 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 and we're going to use brackets on the side because it's supposed to go through. In a similar fashion, please do the same two things for exercise 9. Is it a function or not a function? And then please the domain and the range. Is this a function or not a function? Again, it fails the vertical line test. I'm just going to pick one example area right here. This x value hits the graph at two places. So there's two y values that go along with it. So not a function. The domain of this, again, strike for the obvious. There's no tricks or gimmicks here. What's the furthest to the left that this graph goes? -5. What's the furthest to the right this one goes? Goes to 6. So -5 to 6. I'm going to use brackets because it goes through those points. The range, what's the lowest boundary of my y values? -2. What's the largest boundary? Perfect. Anybody get something different? Anyone not see what in the world is going on? Please don't be shy. I love questions. It means you're processing. Okay, I don't want to leave you behind on this stuff. This is all foundational stuff for what we're going to be doing on Thursday of next week when we come back, and you're going to make 6 new best friends, and you're going to love it. Example 9, I'm going to work this one with you just in case you haven't done one of these before. So example 9, again, first thing, is this a function or not a function? It's a function. If I draw some vertical lines here, notice every time I draw a vertical line, it hits the graph in only one point. So that means this indeed is a function. Then I've got my domain and range. Again, in case you're not aware, the arrows on the end means the graph keeps going in that direction. So my domain, my left and right. What's the furthest to the left this graph is going to go? Okay, it goes beyond -5 because of the arrow. Okay, you would be right if there was a dot there, and you'll see that at some point in the future of this semester. But this one's just an arrow. So that arrow means that if I had the patience, I could keep drawing the graph like this forever and ever and ever. And so that means what is the lowest? What's the furthest to the left it goes? -infinity. And then the same thing over on the right. I've got this arrow. It means it keeps going forever and ever. And so what's the furthest to the right this is going to go? Okay, positive infinity. What do we always use at infinity on our interval notation? Parentheses. Yes, no matter what, you always use parentheses. The range then, the range, what's the furthest down in the y direction this graph goes? -3. And then what's the furthest up it's going to go? Positive infinity. Great job. We always use a parenthesis at infinity. This does go through -3, so I'm going to use a bracket at that side. Same thing for exercise 10. If you would, please go ahead and function, not a function, and then do the domain and the range. Question 1, function or not a function? Yep, it just has to fail one time, and it fails a lot of times, so it's not a function. The more interesting thing from my perspective for you is your ability to write the domain and the range. So the domain is left and right, so the furthest left this is going to go is, yes, indeed, and then the furthest right this is going to go is perfect, thank you very much. And then the range, the furthest up it's going to, the furthest down it's going to go. Yes, indeed. And then the furthest up, I think you'll say, is infinity. And I'm going to put some parentheses. All right, before I leave this is super important. I cannot stress enough being able to look at a graph and write intervals and things is foundational. Is there a question, comment, concern, conundrum? All right, well then we'll just a little bit more, and we're almost done with section 1.2. Since I'm here at the overhead, I'm just going to stay here for the rest of this section. So the last thing is finding function values using our different ways of notating a function. So this example 10 I'm going to do with you says for the function in example 4, which is on the very front page. Okay, so I'm just going to go back to example 4. Down at the bottom on the left gives us these 4 ordered pairs right here. And the first thing we're asked to do is, what is the function value at 3? What's f of 3? Okay, so I look back, and what would you propose to me based on example 4? What is the function value at 3? Okay. Here is the x value 3. That's how my function value works. Whatever's in the parentheses is your x. And so then what's the related y value? The related y value, just as you said, is 5. Great job. So I don't think that's super bad to do, but I want you to practice. So use that same function, find f of 7 and f of 11. What did you get as the function value at 7? Yep, here's the x value 7. The output is -2. I'll flip back and write that in a moment. How about the function value at 11? Is that relationship defined by this function right here? Nope, there's only 4 points. There's only 4 related things. So what we would say, since there's no definition of the relationship, is we're going to write not defined for that one. Okay, so we saw that from that relation that the function value at 7 is -2. The function value at 11 is not defined. The key thing I want you to remember about function notation is that whenever you have an f of x, the output is always a y value. This is another way, f of x is another way to write your y value. You're putting your x value in the parentheses, you get a y value out. Okay, that's going to be important probably in the next section when we talk about solving equations, and we have to be aware of what the notation f of x means. So just a few more of these, so that I feel like I've done a thorough job. So we're going to go to the function in example 5, which is on page 2 at the very top. It's the first table that we did. So for the table in example 5, find the function value at -6 and the function value at 11, please. From the table, the function value at -6. What is the function value at -6? 2. And what's the function value at 11? Okay, it's fine that those are the same y values. Okay, it just matters that the x corresponds to a single y value. So both of these are equal to 2. Exercise 12 says do the same thing for example 6, which is the first mapping that was a function. So for the first mapping in example 6, find the function value at 7, find the function value at -8, please. Here's my mapping. And I asked you what the function value at 7 was and what the function value at -8 was. So what does the mapping tell me is the function value for 7? Okay. 7 corresponds to 5 by that arrow. And what does that mapping say the function value for -8 is? Perfect. You caught on. It's not defined. Yes. So 7 corresponds with 5. -8 is not defined. You still with me? We doing okay? We're hitting the finish line here. We've just got a couple more problems. Exercise 13 asks you to look at the graph in example 9. No, not example. Yeah, example 9, that parabola, which is what that's called, bottom left graph. And I just asked you what the function value at -2 is. Can you read that graph and tell me what f of -2? I hear lots of numbers. Let's see. I've kind of made a big mess of mine, but we'll see if we can work it out. So when I go back to the x value -2, I'm right here. What is the y value of that point that I've just darkened at the x value -2? The y value is 0. So that would be the output here for that. Everyone see that one? That's particularly important, being able to read our graph. Everyone see why that was 0? Okay, last skill. Example 11. I've defined a function for you. So this is the final way. We've talked about sets of ordered pairs. We've talked about tables, mappings, graphs. The last thing is your relation might be given to you as an equation. I tell you it's a function because of the notation f of x, and we're to find the function value. This is just plug and chug. So I'm going to do the first one, and then I'm going to have you practice a little bit. So if I need to find the function value 4, here's what we're going to do. We're going to plug 4 into that. Now, what I like to do, just because I like to be careful of my signs and everything, I'm going to say 5 minus, my original function is 5 minus 2x. So 5 minus 2, and instead of an x, I'm going to leave a space with some parentheses. And now I'm going to fill in the parentheses with whatever I am given, in this case, 4. At this point, just becomes an order of operations problem. Multiplication comes before subtraction. So please do not say 5 minus 2 is 3, and 3 times 4 is 12. That's very wrong. The correct answer is 5. Negative 2 times 4 is negative 8, and 5 minus 8 is negative 3. So please do the one right below that. For that same function, 5 minus 2x, please determine what f of negative 5 is. First thing I'm going to do is rewrite the function without the x. So I have 5 minus 2x. So 5 minus 2 times some parentheses. And in those parentheses, I'm going to put in the value that I'm evaluating. So that's negative 5. Again, multiplication comes before subtraction. So that is 5. And then negative 2 times negative 5. A negative times a negative is plus 10. And then 5 plus 10 is 15. Anybody get something different? Are we doing okay? All right, final 2 problems. Exercise 14, I've increased the level of difficulty of the function just a little bit. So if you would please determine what the function value at 2 is. We'll do them one at a time just to make sure we're all on the same page. What is g of 2? Again, the first thing that I like to do is I like to rewrite my function with gaps instead of the x's. So I have 3 times x, so 3 times my parentheses, minus 2 times x squared. So the parentheses are going to be squared. Remember, this x squared, this square only applies to the x in this case because there's not parentheses. So you're not going to square the 2 that was already there. Okay, so now I'm going to put 2's in these parentheses. Order of operations says let's do my my exponents first. So, and you can do more than one thing at a time, but I'm going to just take it slow. So my exponent 2 times 2 is 4. I'm going to multiply. So 3 times 2 is 6. Negative 2 times 4 is negative 8. And then 6 minus 8 is negative 2. Again, the reason I'm giving you these problems is also I want you to make sure that you're comfortable with signs and squaring things. Okay, these are kind of fundamental things, and if you're struggling, then I want to get you the help you need before we increase the level of difficulty. Okay, last problem for this section. What is g of negative 3? As with previous problems, first thing is I'm getting rid of the x's. I'm putting spaces there. Now I'm going to put a negative 3 in both those spaces. So again, the first thing I'm going to do is I'm going to do that exponent. So I've got 3 times negative 3 minus 2. Now negative 3, that negative came with the 3. It's part of what I'm squaring. So this is sometimes a missed part of this problem. Negative 3 times negative 3 is a positive 9 now. So 3 times negative 3 is negative 9. Negative 2 times 9 is negative 18. And negative 9 minus 18 is negative 27. All right, before I stop the recording, before I move on to the next thing, does anyone have any sort of question, comment, or concern about Section 1.2, functions, function notation, domain, range, all that good stuff.